Hello, and welcome to The Explainer. Today we're going to talk about a kind of invisible power, something that sets pretty much everything in motion. It's called potential energy.
Okay, so let's just dive right in with a little thought experiment. Picture this. You're at the very top of a huge roller coaster. The car is perfectly still. There's no engine. Nobody's pushing. So when you suddenly plunge down that massive hill, where does all that incredible speed actually come from?
Well, the answer is this really cool concept called potential energy. And maybe the easiest way to think about it is, well, it's energy that's just stored up, waiting for the right moment to be used. It's literally energy in waiting.
Now, if we want to get a little more specific, potential energy is the energy that's stored inside a physical system. See, it's not about how something is moving right now. It's all about its position or how it's arranged. It's the energy that has the potential to turn into something else, like the energy of motion.
Think about a giant wrecking ball, for example. When the crane lifts that heavy ball way up in the air, it's working against gravity, right? That energy doesn't just disappear. Nope, it gets stored up in the ball's position, just waiting to be unleashed. Or, hey, think about something simpler, like a rubber band. You know that feeling when you pull it back? By stretching it, by changing its shape, you are loading it up with energy that's just itching to send something flying across the room.
And yep, it's the exact same idea with a compressed spring. All the effort you put into squishing it down gets stored right inside its coils, ready to burst back out. In every one of these cases, the energy is stored just because of where the object is, or what shape it's in.
Okay, so here's where it gets really interesting. This energy in waiting isn't just one thing. It actually comes in a few different and pretty important flavors.
So first up is the one we're probably all most familiar with, gravitational potential energy. This is just the energy of height. It's the energy stored in an object whenever you lift it up against gravity, kind of like all this water held at the top of a giant waterfall. And here's the key thing to remember. There are two big factors that decide how much gravitational potential energy you're dealing with. The heavier the object is, the more mass it has, and the higher you lift it, the more energy you pack into it. So a bowling ball at the top of a building has way more potential energy than a little tennis ball. Then you've got elastic potential energy. This is the energy you store in something when you deform it, when you change its natural shape. It's exactly what an archer is doing when they draw back a bowstring, storing up energy that's about to become the arrow's motion. And this is a perfect way to see the difference. A spring just sitting there all relaxed, it's got no stored elastic energy. But the second you stretch it out or squish it down, you've loaded it with potential energy and it's ready to do some work.
And seriously, once you start looking, this idea is absolutely everywhere. The energy locked in the chemical bonds of the food you eat or the fuel in a car. That's chemical potential energy. The energy between charged particles in a battery. Electrical potential energy. The list just goes on and on.
So, we have all this stored up energy. But let's be honest, the really exciting part is the transformation. How does this energy in waiting get released and turned into the energy of movement? That energy of movement, by the way, is what physicists call kinetic energy.
And if you want to see this energy exchange happen in real time, there is no better example than a skateboarder on a halfpipe. It's basically our roller coaster, but for the real world. So, look at this. At the very top of the ramp, for that split second where the skater just hangs in the air, they're motionless. All their energy is potential energy because they're at their highest point. Their kinetic energy, the energy of motion, is zero. But as they start to roll down, their height drops, right? So their potential energy starts to go down. But that energy isn't lost. It's being converted directly into kinetic energy, which is why the skater starts picking up speed. The amazing part is, even though the types of energy are changing, the total amount of energy stays exactly the same.
And then, bam! By the time they hit the very bottom of the ramp, they're at their lowest point. So their potential energy is basically zero. All of that stored energy from the top has now been transformed into kinetic energy. And that means they are moving at their absolute fastest.
This beautiful dance back and forth between potential and kinetic energy, it demonstrates one of the most fundamental laws of the entire universe, the conservation of energy. In a perfect system, without stuff like friction getting in the way, the total amount of energy never ever changes. It just switches forms.
Okay, now let's pull back the curtain a little bit and look at a couple of clever secrets that physicists use when they think about potential energy. These really make it a much more powerful idea.
So, secret number 1, the point you decide to call zero height or zero potential energy is completely up to you. It doesn't matter if you measure the height of this book from the tabletop or from the floor. What's actually important, what really matters in the physics, is the change in potential energy between two different points.
And secret number 2. Now this one's a little bit of a mind bender. Potential energy isn't really stored inside the ball itself. It's actually a property of the interaction between the ball and the Earth. It belongs to the whole Earth ball system. Think about it. Without the Earth's gravity, the ball wouldn't have any gravitational potential energy at all.
Phew. So, after that whole dive into the world of stored energy, what are the biggest, most crucial points to remember about this incredible power of position?
All right, let's nail down the 5 key takeaways. First, potential energy is stored energy. It's all about position or state. Second, the 2 main types you'll run into are gravitational, which is about height, and elastic, which is about shape. Third, that potential energy is always ready to transform into kinetic energy, the energy of motion. Fourth, the total energy in a closed system is always conserved. And finally, that mind-bending one, it's a property of an entire interacting system, not just one object.
And that leaves us with one final thought. Just take a look around the room you're in right now. From a book sitting on a high shelf to the pen on your desk, where is all the hidden potential energy just waiting in plain sight to be released?